Thank you very much for attending our presentation today. Today I'm going to talk about the IDE that actually we built on top of JupyterLab. I will actually not go through the details of technical issues. It's not possible something that we can discuss in like half an hour, but we'd be more than happy to answer your questions after the session, or you can reach me out. I will share my contact with you anytime. Starting about myself, my name is Marami. I'm one of the founders of Our Brain. I'm one of those guys that actually shifted from pure engineering to data science. My undergrad is electrical engineering, but eventually I ended up to PhD in finance doing just modeling. But I don't regret that. I'm really happy about my shift. About Our Brain itself, our mission is to build an advanced IDE just for data scientists. We see a lot of tools in the market supporting software developers, huge actually improvement we observed in recent years in this field, but still we see that actually an IDE built for particularly data science supporting multiple language is something that is already missed in the market. So this is our mission, to build something on top of JupyterLab supporting open source languages. Our products are, we have a data science platform. It's available on public cloud. You can easily go open an account. It's subscription based. You can use and run your model, share your model, scale in and scale out. And also we have a private cloud service. You can actually implement the same service on your private cloud. And also we have on-premises version it's IT people love it because it's really easy to install and also scale. We have also separate services for if you want to integrate this IDE in your platform, in your data science platform, for example. We are actually happy to help you out. And if you are willing to develop any special kernel for any particular languages or services in your firm, also we can support you. So talking about data science IDE. So what are the main elements of a data science IDE? So definitely it's an IDE. It should have language support protocols, and it should actually have some services, content assistance, syntax coloring, autocomplete that actually we are expecting, and we know that because data is involved in data science IDE, those particular services become a little bit more complicated as just an IDE for software development. We expect something that supports R and Python or Scala. Those are actually most popular languages in the market. We see that there is actually a separate ecosystem for R and Python in terms of IDE and tools, but we see a lot of overlap and see that data science, say full stack, now actually needs to know both of them. And it's really definitely helpful that they don't need to change the tool when they switch between languages, for example. Data and environment view is another element that's really helpful to have it in the IDE, import-export of the data. Debugger is really an important issue. We see that now the algorithm codes are getting more complicated in this domain, and definitely advanced research debugger helps the data scientists out to have actually more efficient development. And of course, more importantly, it should have support notebook. We cannot live as a data scientist without notebook anymore. And for this choice, JupyterLab is a perfect choice because it's an integrated computational environment. So probably you just attended in the session of JupyterLab before today's talk. I don't go through to the details of JupyterLab itself. But you know that actually it's good that it's feature parity with conventional notebooks, say 99.9%. It has flexible layout, which is amazing, that you can set up your environment as you wish. It's extensible through APIs, and it's a fantastic choice. So in July, just 5 months after we started to develop our own IDE based on another tool, when we just engage in Jupyter project, then we switch to this tool because of this reason, and it's really hard to be reluctant to these fantastic features. But we had also challenges with JupyterLab. As I mentioned before about the elements, those elements, many of them are missed in JupyterLab. So we started to develop things on top of that. And these are the challenges that we face and we try to resolve. So one thing was, that JupyterLab as out of the box comes from CodeMeter editor. It's a very nice editor, but still it lacks for extra features that we are looking for. And we found at the same time, we were lucky that Monaco was actually released, which is the heart of, they actually separate out as an API of VS Code, which could be used in another platform like ours. We just learned about that and found it a real good choice to be integrated in our platform. So to be replaced by CodeMeter to bring us extra service. And of course, Monaco is much lighter and faster when it comes to issue of performance. So to resolve this issue, to replace the Monaco editor with CodeMeter, we just submitted a pull request and we decided to go really high level. We just abstracted the editor element inside JupyterLab, enabling people to use their own IDE. We submitted that pull request and we got fantastic support from JupyterLab, the core developers. We worked together, and now we have actually Monaco editor as part of our editor, which is a significant improvement. And as I mentioned, users expect to have a nice support for R and Python and Scala and other languages. So the kernels are available for just adding these features. IPython is really mature and fantastic kernel. That's you know better than me actually. We didn't need to do that much on top of that. Though we just added some extra features that I will discuss. But IR kernel was pretty challenging for us because when it came to just a real kernel that helps users to have like real-time streaming, SCD in, SCD out, HTML, rendering different HTML outputs, Shiny support, R Markdown, or debugging, IR kernel probably is able to handle that, but with a lot of effort that actually you need to put on that. So we resolved that issue by developing R kernel from scratch. So we developed our own R kernel to be able to support our extra features that actually are available in our IDE. For data and environment view, for R, because we developed that kernel in-house, we didn't have, that was part of the structure that we started from the beginning. But for Python, so the kernel protocols extension, which is called COM, couldn't handle some communication that we were expecting, especially for debugging when we are in the pause mode. It was actually, we could lose the states and couldn't have actually a communication to serve the debugging and for the user. So what we resolved this issue by adding the messages, separate message channels for environment view, for data viewer, for debugging, and also for opening the non-local packages. This service is particular for R. And also we develop a front-end comp per kernel to make this communication two direction. And also we changed the way that actually kernel requests a process to enable handling of COM messages. Again, mainly to be able to handle our debugging process for Python. So those actually are built on top of IPy kernel, so IPython kernel. That means actually we didn't change anything at that IPython kernel. All services that you expect from IPython, still you have it, but on top of that you have these services that I explained before. And we did also some extension on JupyterLab. So those were mainly the infrastructure part or server side of the IDE that we built, but now it's time to bring over those services to the users. So we started to extend JupyterLab itself. So we developed an environment widget, a data view, a visual debugger with call stack for Shiny and Markdown, Monaco editor integration that I explained before. We also hooked up the language support protocol, the LSP standard, that, for example, providing the language support for Python was pretty straightforward, but the LSP for R is developed in-house again. So we made some changes in indication of the global kernel because now we have several languages with different services. So user needs to be aware what is the global state of the kernel that I will show you. And we also develop a SQL kernel for make actually the communication to data server much easier for users. We know that you are able to run SQL script inside Python, inside write through different packages, but the problem is the content assistants sometimes coming in to understand the structure of your data or having a view of the schema of your database and see actually which table or which view you would like to use. Those are challenging that we try to resolve by introducing a separate kernel for that. All right, so I stopped talking and switch to demo. All right, so this is just the outcome of the MB convert of one of the notebooks that's developed and run with our own R kernel. You see that different HTML output and rendering of data actually is already there, and these are actually native code. So without engaging any particular coding or adding any script, this is exactly the same feeling that you run the same library or script in other tools. You can simply see that it actually gets rendered here. And all type of the leaflet map, or even 3D graph things, everything actually we now support that people, when they actually develop a notebook, they are actually able to just to run it right away without any extra work needed. And going back to our IDE itself. So here is JupyterLab. Now you are familiar with. The right-hand side, you see actually a couple of tabs that you don't see in standard JupyterLab. This place actually is the environment view, the call stack for debugger, and just a separate view for controlling your breakpoints. This is actually the widget that I explained we added to support for extra services that I explained before. And just give you an example for like running a simple loop in R, you see that we have the online streaming, whereas in IR kernel, for example, everything actually is processed and just send it out as a batch. This is just one example of the limitation that we've been faced. So as the example that I show you, this just see natively you can write any type of the outcome you expect in R, for example, that the R kernel handles that. And on the right-hand side, you see that the environment view and data frames actually gets updated right away. So that's exactly the same thing for Python. We have the same support that I will show you later. Coming back to our editor side and also the content assistant side, inside your notebook, as I mentioned before, like for example, when I start to plot something, the content assistant actually just started to come in and define a data frame here. It's just shows on the environment view. You can go through, just navigate through your data frame. Also double click on your data frame. You can go through and just filter and even you are able to define some particular condition. For example, you are looking for those with 8, and you are able to just export them as a flat file right away to your workspace to be used for your further processes, for example. So we try to make the environment, the beauty of JupyterLab is actually its minimal style, that everything is there, but it's not crowded. So you have a very nice access to different tools without confusing to, a complicated menu structure, 1,000-word keyword listings. And this is we try to keep the same minimal style inside JupyterLab. It was kind of challenging to provide a nice user experience interface. So, but we are working on that. Definitely, we appreciate your feedback for improvement, but we try to keep the goal of simplicity in this environment. Same thing when you define any library that already installed. For example, it gets index. It just brings you over to your console. You are able to install any kind of packages that you would like. Same thing that actually are already indexed. For example, if I go and install, start the console here, for example, you can install any packages. For example, APC, you see that the index coming in and help you out to just install what you would like to use. So that's about running your notebook. And also just talking about R, if you would like to run a Shiny app, for example, also as I mentioned before, we do the support for that. So this is an example of Shiny app. So you can simply run your Shiny app. I need to just turn off the other kernels. So you see that you're able now to run your Shiny as you do in other IDEs without any problem. And also going to debugger then, which I'm sure that many of you are interested in. Just before that, by the way, we also support the Markdown. You can actually run Markdown file. When you just do the rendering, the outcome actually is generated. And you can see that HTML outcome is there, and you can drag it and drop it anywhere that you would like. You see that the outcome is already generated. You can just work on your Markdown file side by side in different iteration. And also, it's not only for Markdown inside your editor, you are also able to run inline rendering. Just you need to trigger this inline, and when you click this, you see the outcome inside your editor. So you can save the space. If you see the console, you want to see the outcome in the console, but if you want to see the outcome right away inside your editor, you can trigger the inline. It's not just for Markdown, for any other editor. I'll show you can actually use that. So going back to the debugger and Python file. So here is actually an example of Python file. Let's just, when we execute a Python script, oh, what happened? Oh, I think I have. Just a simple graph I just generated here. So as I mentioned before, you have the same service here. If you just select the section that you would like and turn inline rendering, you can see the result inside your editor, as I mentioned. So it's the same service for any other editors that you would like to use. So any other kind of services like commenting, uncommenting. We have actually, by leveraging Monaco services, we have a nice actually context menu that actually helps you out to comment, uncomment, format your documents. You can use that also. And just the example of debugger, let's close them. It's a little bit crowded here. So when I run this script, I have actually a function already processed there. So like when I just run my function, just 1 to 10, and if I set a breakpoint here and call back my function, it hits the breakpoint, and that's the place that you're able to do and start your debugging. So here's that you can actually step in multiple steps, step out, or even you actually are able to go step by step and see the outcome, like 1, 2, 3. It just follows you and show you exactly inside your editor. And anytime that you can actually finish your process and stop the process right away. So by the way, anytime inside your editor, you're able to see the global environment as well as the local environment. That's a very helpful tool when you face any problem in your code, of course, that actually you can go through. The same service actually is available for R. So before that, let's process this service. So same function I have just generates a series of code, and inside my debugger, I'm able to set up my breakpoint and calling my function. It hits the breakpoint again, and that's again I'm able to just do step in and step out. What is actually we did extra for our debugger is we can you can actually add breakpoint inside the packages also. So if you would like to call any other packages and you wonder what's going on inside the process, you are able to set the breakpoint now inside those packages. And you don't see the message of source is not available because of the binary installation, for example. You have here a transparent exposure of your R code that you are able to go through any level of I would say, stages of calling library of libraries and set breakpoints and do the debugging even at the package level. When you have actually a CSV file also, it's good to mention that. I discussed about import and exporting data. This part, we also try to make it simple for user as much as possible. Here, for example, when you open up a CSV file and you have the active kernel, here it's my R console, you can simply just bring it over as a data frame in your environment. So you call the CSV file, you open up, and now it's part of your kernel, and you can work with that. So it's the same thing. When I have the CSV file here, let's again just to close these things. And I change my state to this kernel. By the way, you see that when I switch my focus on different console, you see the environment changes, just walking through step by step with you. So when I have the CSV file, just open it up and do actually the import. Now it goes to as a Panda data frame inside my Python kernel that I can actually work with that. So it's really easy now just to see your CSV file, flat file, go through and bring it over to environment and start to work on that. And it's actually bi-directional. So when it turns out to be a data frame, with any iteration and filtering that you apply, you can export it again as a flat file and use it. So we are going to support also other formats like Feather, for example, which is a very nice tool for communication and transporting data between environment. This is, for example, as additional services that we are going to add for import and export data. But the infrastructure is there, and again, as I mentioned before, we just try to make it really simple and easy to use for our data scientists. And as I mentioned before, we also have a SQL kernel that is built for helping out data scientists to have an easy communication with databases. They can run the script, and then after that, when it's mature and it's ready as part of your code, you can simply copy and implement it in the body of your Python or R code. You simply just define your kernel as a SQL kernel, and when you run the connect, these are actually the different type of connection that we support. So you define for example, if you want to run MySQL, for example, you enter your URL, credentials, and get access, and you're ready to go. So, or if you have already created a connection, you can simply say connect to, and make your connection already saved and encrypted, the credential there, by the way, and you establish your connection, and the environment now is changed to schema view. So you have the tables there. You are able to navigate through your tables. You see the columns, and again, in the same environment, this is that you have R, you have Python, you have SQL. You don't need to change your tool for just having access to different environment. And also, same again, when you pull your data, you can export it as CSV file or any other flat file that you would like to use for your work. You can run any SQL script, like, for example, here, content assistant coming in, help you out to select the table that you would like. For example, you select empty car, and again, here, it helps you out to select the column that you're looking for. These are the services that I mentioned that it's hard to implement as part of, for example, a script that is running inside Python or R, for example. So here you choose display, and also you say these two, for example, and you run your code and see the outcome right away. And you can use the view magic and send it as a view here, and for just do extra filtering that you would like, or navigate through, or export it as a CSV file, for example. Same thing also goes in opposite way here. If you have for example, a CSV file that you would like to bring it as a table inside your server, same thing. You just select on it, and as it goes and creates a table based on your CSV file. So that's all pretty brief about the SQL server also. We have about 10 minutes. I can actually answer any question, things. I went, I think, a little bit fast. Okay. Yes, please. Oh, thank you. Question. I think so. I'm not actually able to answer 100% about that. I'm not actually in this particular case, but I can check it out. But what I know actually is possible. I can check it out for you, sure. Here I show my contacts, by the way, that you can reach me, send an email. I will answer it, sure. Yes. Is this all proprietary code? Yes. Some part of it actually just we contributed, like the editor abstraction. Even Monaco, we have actually pull requests for that, but still it's a discussion whether going to be as part of the JupyterLab as another extension, for example. Monaco itself is also some issues for just to be shipped as a package. It's a long discussion that we have with core developer of JupyterLab. At that stage, those actual contribution was really helpful to integrate that, but we are in the process of making it open source, but at the end, it's just about the business model that we are following and finding a way to support to the community. But our interest, our goal is just make all of them open source. That one actually could be a good candidate. It's much easier than the others. If it's your interest, I would say yes. Yeah. Sure. Yes. On any Jupyter notebook, you mean? No, it's standard, yes. But it's actually, we use JVM to support our kernel, our own R kernel. So you need actually to have the JVM. But yeah, it's actually standard. It's going to be hooked as, you can register it as a standard kernel for your notebook, yes. Yes. I have one RStudio guy here, actually. It's the comparison to RStudio. RStudio is a great tool. It's definitely, in particular for R. I don't underestimate what actually is built in RStudio. I learned R with RStudio. It's really appreciated, but what I can tell that all services that RStudio support now is available in our tool. Some particular UIs, for example, a visualization of packages, for example, is not in our tool. It is in RStudio, for example. The reason that actually we didn't go that far because our goal is to make it a multiple language. Those package view, for example, is something that is particular for R. And we would have several tabs or icons for different services. But what I can tell you is that for coming to the language support, content assistance, supporting Shiny, Markdown, those services, actually, all of them are available in our tool. And the main advantage of Write, this is the tool that we call it at RBrain, is you have other languages that you can actually use compared to RStudio. We didn't want to invent a wheel, for example, by developing our kernel. We worked a lot on IR kernel at the beginning, and eventually we found out the thing that we need to add on top of IR kernel is more than that we start to develop something from scratch. Especially for IR kernel is really developing R itself, and R is not something that built for these kind of services that we expected from the beginning. Like, for example, RStudio itself, as far as I remember, it's the service is built something with C++, for example. So that's it. We use JVM in our service and decided to develop something from scratch in particular for the HTML rendering and std and std out. And the third one, which was the most important one, was for servicing of debugger. This R kernel is something that we hope that's going to be actually something that be a good choice for being open source and be public. Then we really believe that it fills a lot of gap between Jupyter and our, between our ecosystem and Jupyter that are using Python only. It fills the gap. So we we can't imagine at the moment any services that you can actually use in R Studio, for example, which is the main tool for R, that you are not able to handle it through our own kernel. Yes. Yes. No, it's just server extension. IPy widget, we support that, but it's not used for that particular purpose. No, it's completely separate server. But we built an extra COM channel on top of IPython kernel to be able to serve that data view, because we didn't want to make it like, for example, when you have a large a data frame with high number of columns, for example, especially it happens in large data set in deep learning. You have like 50,000 of rows of part of that. Then it's going to be forever to start the process and put the kernel on the actually pause position to render the outcome. So that's actually we decided to have a separate channel to avoid any this kind of conflict between the process and the rendering of the outcome in the data view, for example. As I mentioned before, the service is available on public cloud. We appreciate your feedback. It's free. You just use your email address. You can open up an account and use, and let us know how do you feel. And any bugs, issues, we really appreciate your feedback. And also, we are working continuously and closely with the JupyterLab core developers to provide these extra services available to the community as soon as possible. This is our goal, and we are still working on it. And of course, before that, any kind of improvement is needed. We are actually still supporting that and working on it to make it really a fantastic tool for data science. JupyterLab is a beautiful gem, I would say. It's a big responsibility to work in this precious part, and we try to just add extra value on top of that. It's a big responsibility, but we are happy that we have a good support from JupyterLab core developer, and we really appreciate that. All right, thank you very much for your attention.